Okay, I think we can just start it here. So, hello there. My name is Brian, and I'm joined with John today on a workshop on a brief overview of websites and how they work. So to start it off, we're going to have John kick off with some SQL and some databases.
So hello everyone. Today we're going to look at how websites work, but we're not going to look at the client of the website. We're mostly going to focus on like the deep level of the website, such as databases and HTTP requests. So first, we'll start with something called SQL. And SQL is essentially a programming language that you use with databases to convert databases so that like other people can read it. So today we have database for pretty much anything. So for like businesses, games, or websites. And something that controls this database is SQL. And so that we're going to learn. And it's very important in the field of web development and also game development, where we need database. So what are some examples of database? Well, basically username and password that you use in games or pretty much websites like Amazon, or maybe the product you purchase in Amazon can be stored in a database. And we can use SQL to manipulate this database so that we can convert it into things that we want. So such as adding database, updating database, or deleting database, depending on the situation. We can also perform a bunch of other data operations with the database, so which is important in organizing data into pieces and flattening data. So what is a database? A database is an organized collection of data, and it is usually organized into tables. And the reason why we use database is we can get real-time data and actual data from these databases that we can use or display them into clients. So you can think of databases like spreadsheets into columns and rows that contain some kind of organized information. So we need to use, first of all, we need to use SQL in order to convert database, because these databases are stored digitally. So we don't have these paper files of database like we did before. We actually store them online. And in order to access them online, we need to use SQL so that SQL converts these program database into English so that we can read it. And a table is just database of columns and rows that represent specific information. So as you can see, we have customer ID, customer name, contact name, addresses, and on and on. And then they're organized into columns where they have specific information. And the thing to notice is that they're differentiated by primary keys and foreign keys. So primary keys are the customer ID that you see here, which is an ID that makes all data different. And this is important so that developers don't run through redundant data. And if we have redundant data, that's obviously excessive, and we don't really need that. And then we have the foreign keys, which is the other information that doesn't have to be necessarily distinct. So all we have to do to refer to these data is get the primary key, and I'll explain that a bit later. And why should we have tables? Tables are important because they're organized. So if we have something organized data that you can see on the right, we can't really refer to something. So for example, we need to, as a developer, we need to request data that we need. So such as username and password, like I mentioned before, or maybe if you're a game developer, you might need to request the current level of the game from the database. But if we have something like this, we can't really refer to them. So, I mean, like it's just, so you have names everywhere, and then you have prices everywhere, and then you have the type of card everywhere. So if we wanted to take out people who are using the Visa card, then we can't really do that here because it's really unorganized, and we can't refer to a specific column in this case. So it's important that in order to add, update, and delete these data, we need to have an organized data so that we can visualize this structure. Okay, so here's an example of an organized data where you have 3 columns. So the student ID, the name, and then the operating system. So the student ID is kind of a primary key here where we make every student distinct so that we can refer to specific rows of data. So if we wanted to get the names of the students and then their operating system, simply we would just refer to them their student ID so that we can refer to distinct rows of data. Obviously, this is important because if we refer to the names, that's not really going to be accurate, and that's going to give you redundant data because they could have the same names. And obviously, same goes for operating system where they could have the same operating system. So next is a query. So as we discussed before, we need to actually request the data. So if we have, let's say, McDonald's, we need to basically return the price of the data, the order item, and the name of the person who ordered the item. And then we store that into a database. And to actually request the data and actually print out that receipt, we need something called a query. And a query is simply a request for a certain data. So we need to request for a certain data in order to retrieve all the information about that data. And so, for example, if I wanted someone with a certain address, then that would be an example of a query. So let's say we return someone with an address of this, then we would get this row of information. So this is important in fetching data, especially if you're a developer. You need to fetch some kind of data to display on the screen, and you do that using something called a query. So SQL, so now I've explained before basically what a database looks like and what we do with databases and the importance of database. And now we get more into the SQL part. So SQL stands for Structured Query Language. And as I discussed before, it's a programming language that's used to manage data held in a relational database. But also sometimes like there's databases that are not always relational, and they're called non-relational database. So they're kind of databases, if you heard them before, like MongoDB, and they just fetch in a different way, and they organize their database in a different way, but we don't need to worry about that right now. But even though it is called a programming language, it is similar to HTML or CSS, which is like a simpler language than Python or Java, which is object-oriented and more complex. So as you can see on the bottom, here's an example of SQL code syntax. And we're not going to get deeper into SQL code because I want you guys to understand the concept first, because it would be easier for you guys to understand in the future. But basically what this means is that there's a select keyword and a from keyword, and this star just means all. So what this reads is that select all from customers, and this customers refers to some kind of table. So all this is saying is select everything from customers. And then we have something like this, where we select only the username from customers. So this way, we are able to retrieve information that we need to satisfy our needs. So the most important part of SQL, and if you're using like MySQL or PostgreSQL, you need to understand relational database. And relational databases they exist to perform data operations so that we can link these data into meaning to create like this entire meaningful data. So let's just again take Amazon, for example, where we have customers, staffs, and then we have a bunch of other information about like products. And we have these distinct tables that are not obviously related to each other because they're completely different. And then what we're doing with relational database is creating a relationship. So we're linking this table with this table, and then we're linking it to other tables so that we create a meaningful data. And then developers can actually fetch that database to use it later. And when you work with relational database, there's these types of data relationships that you need to understand. And this could be a little bit boring and complex, but this is very important when you become a developer, when you work with database. And this is actually used common, even if you don't use SQL. When you work with JSON, or JSON in JavaScript, it's just really important that you just understand these concepts, just in case you run into things like complex data. So the types of relationships is one-to-one relationship, one-to-many relationships, and many-to-many. So we'll take a look at what that looks like. So one-to-one is we have two tables which are distinct in information that can be matched with primary keys. So in this case, only the data that have the same primary keys can be matched to create a meaningful database. So Brian, which has a student name, has a school ID of 1, and that can only match with ID of 1, which is Burnaby North. And 2 can be only matched with 2, which is Alpha. And what kind of relationship is this? Well, it tells us that Brian attends Burnaby North, and then John attends Alpha. Next is one-to-many relationships, and here's where things start to pile up and it gets more practical. So this kind of relationship is more used in things like student portals. And if you're from BC, you're probably familiar with like MyEd. And here's where we would use something like this. So each row of table can be matched with multiple rows from another table using primary keys. So the keyword is multiple rows. So in this case, you can have the same school ID, and then this one data can match and link to many data. So that's why it's called a one-to-many relationship, where one piece of data, which is this, can link to many. And this can create an even more meaningful relationship, because if you link Burnaby North to Brian and John, that basically tells us that Brian and John both attend Burnaby. And then finally, we have many-to-many relationships, which basically have two datas again, but we're kind of combining them into one entire table. So we have the student names with IDs, and then we have the school. And then we're just mashing them together into one table that has a column of the student ID and then school ID. And this is really used in student portals because we would want the grade level of a student, we want the student name and the school they attend, and maybe the grades as well. So with this relationship, we're able to actually link it to multiple data and then combine them into one, where we have this one organized piece of data that defines all the student names and their information. So something that looks like this. So we have the student ID, and that link that shows multiple times on the graph. And then we have the class ID, which also displays multiple times. And what this tells us, as you can see, is that this one student, which is distinct, appears many times on the graph because he's taking multiple classes. So when we fetch and when we put in a query of this data to search for what student is taking, like which student is taking these classes, all we have to do is refer to the student ID, and then it would just roll out all the classes that he's taking. So if I just say select, remember the syntax here. If I do select student 1001, then it would just roll out all the class IDs. So next on to web frameworks. So a lot of times, like Django, for example, is a web framework that uses Python. And instead of writing actual SQL, like select, something from like a table, they just use some model called ORM. And ORM provides a bridge between relational databases, tables, and fields to create them into a Python object. And why this is important is that Python, or Django in this case, can actually fetch this table of data and then turn them into Python objects, which they can turn them into more meaningful data afterwards, and then manipulate them using Python afterwards. So here we're taking this row, which they fetch using their ID. So select ID from this relational database, and then they turn them into classes, each person's. And then later, if you want to manipulate it, maybe if you're familiar with like object-oriented programming, maybe you can do class person extends this person. So that way, maybe you can tell others that they're related, or you can use them in other situations. But this is how you would actually fetch data. And obviously, there's different types of databases. There's not just SQL, but there's MySQL or PostgreSQL that I discussed before. There's also NoSQL and MongoDB, which uses like non-relational database, which are kind of like these, they're not like a organized spreadsheet, but they're just kind of like these trees of data that are like interlinked to each other. And so, yeah. And also another fact is that file uploads also use some kind of things like database. So what I'm trying to tell you here is that like a lot of things use database that you don't recognize before. So if you upload a file into an image, which you see in like Discord or like Skype, for example, you're actually uploading the image to a server, and then you're storing that into a database. So usually you would kind of think file uploads as like, oh, I just upload the file to the client and then it just shows up to the client or the screen, but that's not really how it works. So you store it into a database first, and then you fetch, and then it gives you this link, like a link like this, that you can use it as like a image URL later. So those are practical applications of databases. And yeah. So next, Brian will take over to explain about HTTP requests. And this kind of relates back to the database, and it helps us understand how the client interacts with the database. So Brian, you want to take over?
Yep, I hope you guys can see my screen. Is this working fine? John, can you see my screen? My HTTP?
Yeah, it's good.
Yeah, okay. Hi, so let's continue with HTTP. So what is HTTP? HTTP stands for Hypertext Transfer Protocol, and it is an application protocol for information systems that allow users to communicate data on the World Wide Web. Basically, it allows the fetching of resources such as HTML documents, images, media, etc., and is the foundation of any data exchange on the web. And HTTP is a client-server protocol. This means that the requests are initiated by the recipient, usually by the web browser. Basically, you, the client, are asking for the data. For instance, when you click on a website, you are the one requesting the data. A very easy way to think about it is when you click on a YouTube video, you are the one requesting the data. YouTube would not be the one giving you the video without having you initiating the request. Notably, a lot of tasks run in the background. Like you don't have to do something like click a button to cause a request to send. However, those requests are still from your browser, still from the client. Therefore, you are technically the one still sending it. So you hear me talking a lot about requests. And what are requests? The client, you or your browser, and servers communicate by exchanging messages. And these messages are known as requests. And what the server sends back or responds with are called responses. For an overly simplified model, you can think of a website consisting of two parts, a front end and a back end. These requests basically allow the front end and back end to communicate with each other. A way you can picture this is like when you're texting a friend for information. In this case, you are the front end and your friend is the back end. So for instance, you ask him where the party is taking place. That's a request. And him responding, Lohid Mall, that's a response. Though oversimplified, that's basically how it kind of works. So let's go a little bit more in depth on what the front end and back end is. A complex website can be simplified into two main parts, the front end and the back end. The front end, otherwise known as client side, is what the user sees. The front end consists of the logic for the website. It's a logic that the user interacts with. Like for instance, when the user scrolls to the website, animations will occur, and that's client side logic. The backend, otherwise known as server side, consists of servers, applications, and databases. Basically, the backend it would be able to grab the information from the database when the front end wants it. So let's go into more components of HTTP-based systems. Basically, going a little bit more in depth in the front end and back end simplifications. Between the client and the server, there are a lot of entities. These entities are all collectively called proxies. They can perform multiple operations such as caches. Basically, the cache can be public or private, like the browser cache. Filtering, so basically like an antivirus scan or parental controls. There's also load balancing to allow multiple servers to serve the different requests. So basically, you have like multiple servers, and when the request comes in, multiple servers get to decide which server handles the request. And so not one server gets bombarded with just a bunch of requests and the server just like dies. And authentication can happen here too, to control access to different resources, and logging allows storage of historical information. And of course, there are a lot more tasks that can be done. However, these are just a few basic examples that are mostly used. So let's go a little bit more in depth with requests. There are 5 types of request methods I would like to go over. However, there are a few others such as head, trace, and connect that I will not be going over. So let's start with the most basic one, the GET request. The GET request is when the front end gets information from the back end. For instance, when we click on a website on Google, your browser would send a GET request to the website to request all the information. When you click on a blog, you would be sending a GET request for the data for the blogs. A POST request is when the front end posts information to the back end. Imagine if you have written a blog and you would like to post it for others to read. You would click on the submit button, and the front end of the website would send a POST request to the back end with the information. The back end would then somehow store the data in the database, allowing another user to send a GET request to get the information you have submitted. A PUT request allows you to update information. As shown in the SQL part of the presentation, there is something known as a primary key, allowing the information to be unique. That is how the server would know what information to update. Notably, when you submit a PUT request, you would update the resource completely. For instance, if you have a book with a title, author, and description, sending a PUT request requires you to send the book title, author, and description again, despite the fact that you only want to update the title. I hope you can see how that can cause a bandwidth problem of just a lot of data, a lot of unnecessary data getting sent to the server, and which is not even updated. So a patch request basically solves that problem. Patch requests, you can simply think of it like a PUT request. However, a patch request allows you to update parts of the book. For instance, if you want to update the title, you would not need to send the data with the description or the author. You would just need to have the server recognize the primary key and update the title. And a delete request is pretty self-explanatory. You would just be telling the backend to delete a book. So let's look at this with more of a step-by-step method. So what happens when you really click on a website on Google? So when you click on a website on Google, your browser will receive the website's IP address and will build a connection with the server that matches the IP address to transfer information. Browsers use Internet Protocol to build connections. The most common protocol is the TCP. To transfer data packets between the client, your browser and the server must establish a TCP connection. Okay, I am now going to rant a little bit more about the advanced stuff. And if you don't understand, don't worry. All you have to know is that a TCP connection is established. So the connection is established using a process called TCP/IP three-way handshake. This is a 3-step process where the client and server exchange synchronized and acknowledgement messages to establish a connection. So the client sends an SYN packet to the server over the internet, asking if it is open for new connections. And if the server has open ports that can accept and initiate new connections, it will respond with an acknowledgement of the SYN packet with an SYN/ACK packet. The client will receive the SYN/ACK packet from the server and will now acknowledge it by sending an ACK package. So after having a TCP connection established, it would be time to transfer data. This is when the request would be important. Now your browser would send an HTTP request. The HTTP requests were readable. However, with HTTP 2, these messages were now encapsulated in frames. However, the concept is still the same. And this is not confirmed, and don't quote me on this, but I'm pretty sure now it's converted to binary when sent. So obviously you can't read that. And so here you can see the start of an HTTP request. So here you can see the get, it's a get request, the path, the version of the protocol, HTTP 1.1, and the headers. And I would show you how to find all of these in inspect element later. And yeah, so here you see an HTTP response example. So it starts with a version of the protocol. It shows the status code 200. That means, okay, it worked. And obviously there's other status messages like 400, 43, 201 for created, etc. Yeah. And then after that, you see a bit of information, headers that basically have more information about the device and etc. Like using an Apache server, the last modified date, set ranges, and the content type, etc. So now that you see the start of the request, let's go into the content of the request and the different types of formats the content can be in. So there are multiple formats in which the data can be sent from the front end to the back end. The most readable one is JSON, which stands for JavaScript object notation. Since JSON is the most readable, I would be using it for the rest of the presentation. However, there are a lot of different formats that are worth knowing. For instance, there is a format called multi-part form data. The format is really important if the data you send contains image files or media files or files in general. For instance, you cannot send image files through JSON unless if you use base64, which would have a 33% overhead. And that, I hope you can see how 33% overhead, it might not be that big at first, but if you have like millions of users using it, that would ramp up your server costs and require you to pay a lot more for maybe a really simple server. Instead, you should use multi-platform to have the best efficiency. And one way to get behind this, if you're really familiar with JSON, is to send a JSON to send a request, a post request. If you're posting a book, for instance, and you want to have the thumbnail being sent with a multi-part, so you have a JSON sent to the server, and then when the server responds, you immediately send the multi-part form data with a put request, or sorry, with a patch request with the thumbnail. This will be a good way to implement both. But of course, the best way would be just to use multi-part form for the whole thing. So where do the requests go? Let's say we have a website for books. The server would generate, and I'm using generate with quotations, because it's really oversimplified. It will generate URLs for each book. A more advanced way, still this is really simplified of thinking about it, is that the URL accepts a parameter. So you would see the 23. So books, there would be a parameter called something like ID. So basically the server would accept a URL with a parameter that feeds into a function. And in this case, 23 is the parameter that you feed into a function. So the server would look at the parameter and do a query in the database to see if a book with that ID exists, or primary key. I'm using the term as ID and primary key interchangeably here. And I don't know if there's a real big difference, but yeah. And if the book doesn't exist, the website would, the server would run with a 404. And yeah, that's basically how it kind of works when you see something like, if for instance, if you were to watch a YouTube video, you would see like a chain of like random characters. I don't know if it's alphanumeric. I think it's only alpha, if I'm not wrong. I'm not sure, but yeah. And that's basically how it kind of works. So now let's say we want to read a book. So you would click on the book. Once you click on the book, the front end of the app would send a GET request to the back end requesting the book. And the response can look like the JSON showed here. So as you can see, you have the title, the book name. So this is a response, keep in mind. Later on, I'm going to be showing you the request, but this is only the response. So you see the title, author, and the description. So author 2, as you can see, this is the number 2, and that's going to be the primary key or the ID. Instead of like the whole entire author and all the data that comes with it, it just shows the ID. And next we have, now let's say you want to upload a book. After filling out a form, the user would click submit, right? After you fill out a form for the book, you would click submit. And this would tell the client side code or the front end to send a post request to the backend. And this is what the data sent to the backend will look like in a form of JSON. So as you can see, you have kind of what the GET request, the response is. So you have the title, the author, and then the description. And of course, this is just like an example. Okay, so now you have uploaded a book. However, you notice that something is wrong and you need to fix it. A less bandwidth efficient method would be sending a put request. In this case, you would have to send the whole book data back. So as you can see, I'm sending the whole book back. And in this case, you would have to, including the data that has not changed to the server, and the data sent in the form of JSON would look like this. So you are literally sending the whole thing back. And for instance, if I was just trying to update the title, I'm sending the author and description back, and I hope you can see how that's a problem, especially if the data is like humongous. Imagine if this was like a huge chain of just data and just JSON, and then maybe if it's multi-part, you have to resubmit images, and that would just not be good. And if we do not want to cause a bandwidth problem, we can use a patch request. So if the user wants to update the book, we can send a patch request with only the fields that need to be updated. The data or the request in the form of JSON can look like this. As you can see, it differs from the put request before. Instead of sending the author and description, I'm only sending the title, the fields that need to be updated. So I hope you can see how this is a lot more efficient. And of course, if you don't like the book and you want to delete it, we would send a delete request. With delete requests, you usually do not send any data except for the request headers. So there are no data sent with the delete request. So now I thought I would show you a technology called Postman. So let's see if I can get screen share to work. Sorry, give me a second. So I'm gonna stop the share. And okay. John, can you confirm that you can see this? John, can you confirm that you can see this?
I can see it. I can see it.
Yeah, okay. So so here's a good example of a GET request. So here is a URL that you can find online. And notably, I want to say that I'm not good at using this technology, and I'm not even sure if I'm using it correctly. I simply knew the existence of the application, and I just wanted to play around with it, and then realized that it's really useful when coding. So this is probably not how you're supposed to use it, and there's definitely better and like a more full potential way of using it. However, this is I just want to show you what a total beginner can do with this technology. And here I'm connecting to an API online, and of course you can just copy and paste the URL. And here I'm sending a GET request. So let's see. If I send the GET request, sending request, it responds with the data. And you can see the headers, Postman token, and it's just whatever Postman does. And you can see all the stuff you're sending, etc. And then you can see the headers here of the response, I think. This is the response, I think. Yeah. And you can see the 200 status 200 OK, the time, the size of the response, the body of the response. And it is in JSON, here is XML, etc. And then you can see it raw, the preview, and you can visualize it. That's pretty cool. And of course, I have the server hosted locally here. So let me just change the authentication token here. And let's see if this works. And of course, if I send in, if I retrieve a workout here, I can retrieve the workout like this. And then you see the response. And of course, here's another showcase of that. So here I have my another URL that I'm testing it on. I'm setting a GET request to the URL, as you can see here. I'm just gonna send a GET request. Oops, token not valid. I'm just gonna have to replace this. Yeah, there's definitely a more efficient way to do that, but too lazy to search it up. And here you can see the response. Of course, you can post a workout here. So basically what I'm gonna do is I'm gonna authorize myself again. Here we go. And then the body, what I'm gonna do is I'm gonna, as you can see, name where this workout already exists. So I'm just gonna type some random stuff here. And then I'm just gonna send the request, send the post request. And as you can see, it responds with the data with the 201 created, meaning that the data was requested and it took 15 milliseconds and 577 bytes of response. And of course you have the cookies, you have the headers, etc. And yeah, you can kind of just see how this kind of works. And this is a really cool application to play around with a lot of stuff. And especially when you have authentication, this is really useful. Of course, there's also like HTTP with Visual Studio Code. If you've ever tried that before, it basically allows you to code kind of these kind of requests. And yeah, and as you can see, this is pretty fun to play around with. You can do quite a lot of debugging and testing with this technology, and it is really useful when you authenticate your users with the logging in. And next, I would like to show you a very slight glimpse of the power of inspect elements. I'm sure we've all been there trying to look cool in front of other people. And yeah, so I want to show you a little bit of the inspect element. So of course you just right click and then inspect. And here it's a little bit daunting here at first, and it looks pretty and it looks a little bit overwhelming. However, this is just HTML, and I'm pretty sure we've all played around with just like changing random stuff and then saying really bad things on the website. However, today we're going to be focusing on the network tab. So if we Control R or reload the page, you see what the request, everything that's getting sent when you reload the page. So you can see just a huge chunk of just things. So let's just focus on the first one. And of course, you can see how long it took to take the responses. And this is this is really important for debugging. Oh, and someone messaged on chat. Let's see if there's a question. Yeah. Thanks, Zach. Yeah, I'm not really too familiar with the keyboard shortcuts for Chrome. Yeah. So of course you could see the general. So this is a request URL, and then we're requesting a GET method. It's a GET request, and then it has the static code 200, meaning that it's okay. And then remote address, and then blah 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 blah. And if you don't understand everything here, you're not alone. I don't understand everything here either. But yeah, this is just really cool to look around here, and then you can preview the response. And then here's a response, and this is just like a preview, so you can, like, if it's the response to HTML, you can kind of look at it. And then of course you have the initiate timing, cookies, etc. And this is yeah, this is just really cool to see. And of course this is really good for debugging. So for instance, if you have a resource that's taking, well, this is taking quite a while to load actually, the 6,500 millisecond one. Yeah, that's taking quite a while to load. So you might want to check up on that and see what's happening. Maybe the image file is too big and you can maybe shrink the image file, other things like that. And yeah, so of course you can click around here more and oops, what am I doing here? Yeah, of course you can play around here more, preview these are the images that are here. And then yeah, so that's you can do. So basically inspect elements is really useful. And yeah, I hope you can, as a developer, I hope you can see how powerful this is when you're debugging code, and you can see which endpoints are not working well and what isn't loading properly and what requests are not going through. And it seems like we have a little bit of time. So I'm going to actually continue on with a presentation about a little bit of another subject. We're going to go over the brief. So I thought this is a little bit more advanced. So for the beginners out there, this can be a little bit more advanced. So we have a little bit more time. So I thought I would give you guys a brief overview of authentication. So first of all, what is authentication and how is this different from another word you probably hear very often? So authentication, according to very often authorization. So you probably hear authentication and authorization jumbled around together a lot. And I thought I would differentiate them first. So authentication, according to Google, is a process of or action of verifying the identity of the user or process. So basically, authentication allows the website to know that you, someone accessing the website from some web browser, like somewhere in the world, is actually you. So like for instance, when you log into a website, what actually happens? How does the website know it's actually you, not like some random guy? And of course, you can say it's a password and the user, you can say the username and password, but it's not like every time you send a request to a server, you're re-logging in, right? So how does the server know? And so basically, authentication allows the tells the website who you are, someone accessing the website, yeah. And it's almost twin brother authorization is what gives those to you, the user permissions to access a resource. For instance, if the website has an admin page, only people who are authorized are able to access it. So let's go over the two main ways of authentication. So the two main ways are session authentication and token authentication. So both ways of authentication sends the user a key, which might be stored in a cookie or local storage. And notably, the way the key is sent is a lot different between session and token. In token, most of the time we use something called JWT tokens, if you've ever seen that before. If you were to look at my Postman before, let's see if you can see this. And then if we can, yeah, if we can look at the authorization here, that's a JWT token there. I hope you can see how that could be. That is a lot different. That is different than something like session authentication. Even I don't have an example right now for session authentication, but yeah, that's basically what a token looks like. And both ways of authentication, when the user sends a request to a server, the key is also sent with the request. So basically, when you log in, the server sends you a key, and every time you send a request, the key that the server sends you is sent to the server to authenticate you. And so, what is a cookie? So a cookie is a small piece of data stored on the user's computer by the web browser while browsing a website. Think of it like a .txt on your computer. A quick note is whenever you make a request, the relevant cookies are always automatically sent to the server. So I hope you can see how that can cause some security vulnerabilities. For instance, a CSRF attack, when you click on a website and then they send a request from your browser to the server. And you can see how, because the cookies are automatically included, how the CSRF attack would go through. And so what is local storage? Local storage is abstractly very similar to a cookie. You can pretty much think of it like the same thing. However, there are some major differences. Cookies are primarily for reading server side, and local storage can be read by the client side. So relevant cookies are automatically sent to the server per request, while local storage will not be sent to the server unless specified. So the local storage, the data in local storage will not be sent to the server unless you specify it. However, the cookies would always be sent to the server. The relevant ones, at least, will be sent to the server. And another big difference is that cookies can store a maximum of 4,096 bytes per cookie, while local storage is 5 megabytes per domain. So that's quite a big jump. And there are still other kinds of storages like session storage and things like that I wouldn't be going into today. So session authentication. And this is when authentication where the user state is stored in server's memory. So when using a session-based authentication system, the server creates and stores the session data in the server memory. And when the user logs in, the session ID is stored in a cookie on the user browser. So the session ID, if you saw the token I showed you before, the token is a huge chain of just, again, alpha or alphanumeric, I don't know. I forgot. I'm pretty sure it's alphanumeric. My brain is not working. And yeah, so basically the token is a huge chain of information, and it's actually encrypted. So if you unencrypt it, it could mean logic. So for instance, let's see if I can actually do this. If I go on JWT token decode and then do this, and then here I can copy and paste my token here, and then you can see how the token is decoded here. So data type, token type access, expiry date, and then yeah. So basically this means that. And of course I can change this. So if it's a refresh token, and it's just converted. So yeah, that's basically how it works. However, session authentication doesn't, the session ID doesn't really work like that. The session ID is almost kind of like a primary key in a way. You can think of it like more like a primary key. because the server stores information. So as you can see in the token stores all the information, but for session, the server stores all the information. And a big problem with that is because the server is storing all the information, if you have like millions of users logging in at the same time, you can see how the server has a huge load of just information it needs to keep. And you can probably see how that's a problem. So here's just a brief overview of this cookie and session authentication. So you log in with the password with an HTTP request, post request probably, and then it responds with the cookie and session ID. And then every time you send a request, for instance, you want to send a GET request that requires you to be logged in, you send the cookie and session ID to the server too. And then if you're authenticated, and my guess is case to authorized, if you're allowed to view it, you get a success message. So for token authentication, when users this is when users log in, they receive a unique access token. The user state is stored on the client, not on the server, so it's mostly stored on your browser. The user data is encrypted and mostly stored in local storage and sent as a header for every subsequent request. So you would have to code this in, and you would have to send the token every time you would have a request. So if you're using Angular, and I'm pretty sure React has something similar to this, you would be using an HTTP interceptor, so which is like in the main part of your app, so the root app. So every time you have a component that sends anything, the HTTP interceptor would intercept the HTTP request and add the token in, if there is a token. And the server will receive and validate the JWT before proceeding to send a response to the client. And here, as you can see, it's really similar. It's really similar to what the session is, except it's just different on how the information is stored. And so basically, though we're finishing a little bit early, that's basically the end of my presentation. And yeah, so I guess we can take the last few moments to answer questions or something like that. So if you have any questions, feel free to be asking them.
Yeah, thanks, Brian and John, for leading this great presentation. Everyone can write their questions in the chat or the Q&A, and they will try to answer it.